Okay, number one, they want you to divide using long division. So it's all in order and there's no missing terms. So we're going to have x squared minus 3x minus 40. And we're going to divide that by x plus 5. So x goes into x squared x times. Let's multiply. X times x is x squared. X times negative 5 is negative 5x. Let's change the signs and add down. So you get positive 2x and drop the negative 40 down. X goes into 2x 2 times, so 2 times x is 2x. 2 times negative 5 is negative 10. Let's change the signs and add down. So you have a remainder of 30. So you could write down x plus 2 plus 30 over x minus 5, just like you would when you're dividing regular numbers. This number, the remainder divided by the quotient, or you could write it with the remainder. Either one is fine. Divide using synthetic. There's no missing terms, it's all in order, so let's write the coefficients. 1, 3, negative 1, negative 3. 1, 3, negative 1, negative 3. And because it's x minus 1, let's put the 1 in there. So 1 drop down, multiply, add down. 1 times 4 is 4. Add down, you get 3. 1 times 3 is 3. Add down, you get 0. That's your remainder. That's your constant. That's your x. That's your x squared. So your answer is going to be 1x squared plus 4x plus 3. Number 3, synthetic to find P of A. 3, 2, 1, constant. So it's in order and there's everything there. So 1, 4, negative 8, negative 6. Because we're using the remainder theorem, we'll take the negative 2 as it is. It's not like it says x plus 5 or x minus 2, in which case you'd have to take the opposite. So 1, drop that down. Negative 2 times 1 is negative 2. Add down, you get 2. Multiply, add down, multiply, add down, and that's it. So this is your your remainder, your constant, your x and your x squared, but we don't care about the x squared, the x and the c. We're dealing with the remainder theorem. So your answer is going to be the remainder. In other words, if you were to taken negative 2 and plugged it in here, here, and here, and simplified all that, you would have gotten negative 18. The remainder is your answer. Number 4, use synthetic to completely factor. It's all in order, and there's nothing missing. So 1, negative 4, negative 9, 36, dividing by x plus 3, so we're going to use the minus 3 here. The negative 3. 1, drop it down, multiply, add down, multiply, add down, multiply, add down. Remainder, constant, x, x squared. Because the remainder is 0, that means that x plus 3 is a factor of this trinomial. Not trinomial, but cubic function, I should say. So, x plus 3 times the quotient, which is your answer, x squared minus 7x plus 12, is the same thing as this function. So what we can do now is we can factor this out. X and x, same signs, both of them are negative. Two numbers are multiplied to give you 12, add to 7, that's 4 and 3. So that's your complete factorization of it. Number 5, again using synthetic, 4, 3, 2, 1, constant. So let's write down the coefficients. 1, 3, 3, 4, 3. Because we're divided by x plus 1, we're going to put a negative 1 there. So drop the 1 to get the ball starting, to get the ball rolling. Negative 1 times 1 is negative 1. Add down. Multiply. Add down. Multiply. Add down. Multiply. Add down. Remainder, constant, x squared, x cubed. So your answer is 1x cubed plus 2x squared plus x plus 3. Number 6, again division. With this one over here, you're dividing by x cubed minus 1. So we can't use synthetic division here because it's not in the form x minus k. So let's do long division. So we have x to the 4th plus 4x cubed plus 0x squared minus x minus 4. Wow, that is not a straight line. Let's try that one more time. Divided by x cubed minus 1. So x cubed goes into x to the 4th, x times x cubed is x to the 4th. X times negative 1 is negative 1x. So what we have to do now is we have to add down after we change the signs. And again, you can fill these in if you want. If you want to put plus 0x cubed plus 0x squared, that's fine. You don't have to fill it in if you don't want to. But then we change all these signs. And then we add down. These cancel. This gives you 4x cubed. That cancels. It doesn't give you anything. This cancels. And you're left with minus 4. X cubed goes into 4x cubed 4 times. Let's multiply. 4 times x cubed is 4x cubed. 4 times negative 1 is negative 4. And when you switch the signs and add down, you get a remainder of 0. So the answer is x plus 4. Number 7, find the real solutions by factoring. So let's factor out the GCF. It's in order, so the GCF is x. So x times x squared plus 2x plus 1. We can factor this. It's a perfect squared trinomial. It's x plus 1 times x plus 1. So the solutions, this gives me a 0. This gives me negative 1. This gives me negative 1. So my zeros are 0 and negative 1. And this is a double root. Has a multiplicity of 2. And those are my real solutions. Number 8, use the quadratic formula. So the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So negative 4 plus or minus, we have a 4 down here. 4 squared is 16. 4 times 2 times negative 4 is 32. A negative times a negative is positive. So we have 48 here. Let's break down root 48 up here. That's the same as root 16 times root 3, which is 4 root 3. So when I write this out, I'm going to have negative 4 plus or minus 4 root 3 all over 4. And I see that the 4, 4, and 4 can all be reduced by a factor of 4. So that gives me negative 1 plus or minus root 3. Number 9, simplify the expression. So a negative times a positive is a negative. 4 times 6 is 24. I times I is negative 1. A negative 24 times a negative 1 is a positive 24. And that's it. It's probably the quickest problem that you've had to do yet. 10. Explain why using the remainder theorem might not be the best way to go for the following problem. Well, the explanation's pretty obvious if you even try to use the remainder theorem, because remainder theorem deals with using the synthetic division method. So in synthetic division you have to account for every exponent. So for this one, if you're going to account for every exponent from 124 all the way down to the constant, you're going to have an unbelievable amount of zeros. I mean, really think about it. You're going to have a 1 for this, then you're going to have a 0 for 123, x to 123, 0 to x 122, 0 to 1x, I mean, seriously. It's going to go all the way down. Then you're going to have 4, negative 8, negative 6. You're going to have like 120 something zeros here. Do you really want to do that? No. So substitution's the way to go for this one. P of negative 1 is just going to be this. This is going to be much easier, right? Because negative 1 raised to the 124 is positive 1. This is positive 1 plus 8 minus 6. 8, 9, 10, 10 minus 6 is 4. That's so much easier than having to, by the time you're written down the 20th zero, you would have gotten your answer by using substitution. So that just goes to show that synthetic division isn't always going to be the method of choice, especially when you're talking about the remainder theorem and substitution. So it might not be the best way to go for this because, number one, substitution's quicker in lieu of the fact that you have to account for every exponent when you use the remainder theorem. And when you're dealing with an exponent of 124, even if you had a value for every exponent, I mean, that's ridiculous.